Our next speaker is Mr. Hidayat Khan, Sentelist ME UAE. Mr. Hidayat Khan is a science instructor and also founder and principal security consultant of Sentelist ME, a cyber security consulting firm based out of Dubai, UAE. His previous professional experiences include working as a senior security manager for Scanit ME, head of SOC for Datafort, and as a senior security engineer for Emirates Airline Dubai. He has his CISSP, GCIH, GPN, GSEC, GREM, GHD certifications, plus more than 20 plus years of focused cybersecurity experience, and brings with him a wealth of knowledge and hands-on skills garnered from the trenches in various consulting assignments for a range of Fortune 500 companies across the EMEA and APAC region. His area of specialization includes active defense, threat hunting, cloud security, malware analysis, and incident response. Mr. Khan is also an active contributor to the information security community and has published several articles in leading regional magazines such as Computer News Middle East, Network Middle East, and Security Advisor Middle East. He is also a prominent speaker at various security conferences and has been involved with the SANS Institute as a GIAC advisory board member and mentor since 2001. He has been teaching for SANS ever since and has and taught SANS course at several events. Sir, over to you.
All right. Cool. So thank you for the great and warm introduction. Hello all. Welcome to this second PKI annual conference. I'm really excited to be here and to share my experiences, a little bit with you guys. So I'll be your presenter for the next 25 minutes, I guess. So I will be talking about abusing PKI, right? Very specifically in Microsoft's Active Directory environment. So let me start the session. There's a lot of things to cover and I have very little time, but I hope I will be able to quickly, make into all those important stuff, right? And this topic is very near and dear to my heart because I have a focused 24 years of dedicated experience in cybersecurity. I have been on both sides of the playing field, on the defense of cybersecurity as well as on the offense of cybersecurity, right? So on the defense side, the IR stuff, the SOC stuff, and all that stuff. But my current latest passion is on the offense side, where I'm, acting like the ethical hacker slash red team slash adversary emulation, stuff like that. And this presentation here is more geared towards the offensive side of cybersecurity. All right. And this presentation is based on research from a couple of very respected cybersecurity researchers called Will Schroeder, who also goes by the handle FarmJoy on Twitter, and Lee Christensen, who goes by the handle Tifkin on Twitter. They both work as distinguished, cybersecurity experts for an organization called Spectre Ops, right? And also a hat tip to one of the guys who kind of revolutionized cybersecurity in an offensive way is this guy called Benjamin Delpy, who wrote the famous tool called Mimikatz, right, which is able to pull passwords out of your memory, out of your LSAF process. All right. So this is the agenda for today. I'm going to be talking about the threat. What is that needs some kind of introspection and action. Okay, so very specifically on the Microsoft PKI implementations. I'm also going to talk about the risks posed by this threat, and to get started by knowing about Active Directory PKI implementation from Microsoft, we need to know a little bit of background. So very quickly, I will touch base on some authentication protocols like Kerberos, just to get started. And then I will go ahead and start talking about Active Directory Certificate Services, which is nothing but the PKI implementation of Microsoft. And then some, I would say, inherent issues which results in misconfiguration in the default settings can lead to a havoc situation, right? And I want to show you some demos as well. So very quickly, I have a lot of things to cover. So, please bear with me if I'm going a little bit fast, but the idea is to, crunch as much as possible in this next few minutes. So the threat is Microsoft's PKI implementation, which goes by the name ADCS, Active Directory Certificate Services. It's a very complex system, right? And it's widely deployed. I will just kind of hide video here. Yeah. So hopefully you can see me, the thing here, because the slides are also, yeah, now I think it makes sense for me. So it's widely deployed across the globe. And since it has lots of complexities, and in a default state, if the administrators of the boxes, if they just go click, 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 and they set up a ADCS, it gives attackers ample opportunity to do a lot of powerful attacks on your organization, going from credential theft. Somebody can steal your credentials. Somebody can gain access to your machines and lie, buried and hidden inside of your machine persistently for years together. You can't trace them. You can't, unless you have some very good telemetry and detection stuff. And then, you could also elevate your privileges, and from a low privilege user, you can become the topmost user of the domain with all privileges, which is the domain admin or the enterprise admin, right? So all this of stuff is there for me to cover here. So the risks on account of these threats are, the first and the foremost is, the user credential theft. So if an attacker can steal the existing certificates which are available on the systems, right, he can actually survive any password changes that the user will do. Okay, for as long as 1 year, he can have access to the system. Okay, because the certificate is valid for a year in its default state. Administrators usually, configure it for 2-3 years, but then, in a passive state, if I can steal that certificate, I can have access to, as that user, to that particular system in that particular organization for minimum 1 year. And this goes without, elevating my privileges to become an administrator on the machine or local administrator. I don't have to, inject or do something into the LSAS process. LSAS is a process which is on your Windows system, which will be holding all your credentials inside of the memory of LSAS process. Hackers would love to do something called a DLL injection attack inside of this LSAS process to dump the credentials. But if I want to do this attack, I don't have to even touch that. So they can't see me, the defenders, that I'm stealing the credentials. Similarly, machines have their own certificates. If I steal the machine certificate, right, of a machine, of a database, of a file server, I can have, continuous access to that machine for more than a year, right? In a default state. I can, as a low privilege user, become a domain admin, right? The topmost guy who can have control over each and every single system connected to the domain, okay, with the domain admin privileges. So I'm going to show you some demos here, and also a domain persistence, where if I steal the, private keys of that CA, game over, right? I can go and create myself, some kind of my own CA certificates, 4 CA certificates, which I call it golden certificates, right? And this will also survive. There won't be any revocation as part of this, because it is not coming from the actual CA. It is my own CA, a fake CA, and I'm there inside of the organization for as long as I want it, right? And obviously, all this, whatever I'm covering here, is at the tip of the iceberg, but more such information is available in this paper down here. So a little bit of background information before I get started into talking about Active Directory certificate services. As you all know, in Active Directory, Microsoft Active Directory environment, there are a couple of authentication protocols. One is the Kerberos, okay, which is forked off from the MIT, and it's Microsoft's version of Kerberos. And then the public key initial authentication, Kerberos PK int, okay, which uses certificates, right? So let's quickly go and refresh ourselves as to what this Kerberos is. It's very important for you to follow this little bit of slide, this presentation, this the thing that I'm showing you here, because in the demos, you need to understand how all this is happening here. So here we have on the left hand side a user who's logging in early morning on his system, right? He types in his user ID and password, and now he wants to get connected to his internal domain. So the moment he types in his password, okay, the Kerberos internally on the client machine, it will take the empty hash of the user's password, and along with the timestamp, it will encrypt the timestamp with the empty hash, and it will send it as an authentication request, okay, to the domain controller. Hey, domain controller, it's me, Khan here. Can you please authenticate me? So the domain controller will have the user Khan's password on its database here. So he will, use that password, and then, he will be able to identify that, this encryption that was done is based on that, similar password, the same password which was here, and he will give him a ticket. Okay, this is called a ticket granting ticket, right? So now the user or the client machine will receive the ticket granting ticket. Now he's inside of the domain. He's got connected. Now the next step for him is, let's say he wants to access his mail server or file server where his files are located. So he will again go back to the domain controller saying, hey, domain controller, this is the TGT that you gave it to me. Please take this, verify that I am really Khan, and I want to actually access this guy, the file server. So can you please give me a service ticket to the file server? So the domain controller will validate it as long as it is not expired. I think the minimum 20 minutes, okay, expiration deadline. If it checks out, everything is fine, it will give him a ticket. Okay, here you go. This is the service ticket. And the domain controller will also say, look, I don't know whether you have access to the file server, but since your ticket is valid to me, I'm just going to give you this ticket. So the user will take the ticket back to the file server, which will be actually encrypted with the ticket, with the file server user account here. And this guy can't open it, and that's how he can get access to this. So an analogy that I like to explain this in a much more clear way for a 5-year-old, right? I mean, this is how I teach my son cybersecurity. Let's say you take your 6-year-old to an amusement park, and you go to the entrance gate where there is a ticket booth, right? And you buy a ticket. So the ticket guy will check, your validity, your ID card, and he'll give you a ticket. So that ticket is the ticket granting ticket. Now you take the ticket and you enter the park. So you're already inside of the park. And now your son says, Dad, I want to go to the merry-go-round drive. So again, you go back to the ticket booth and tell him, hey, can you give me a ticket for that merry-go-round, right? So the ticket collector, he will see, okay, you've already inside the park and you have a valid ticket. Now he will give you a ticket which is just for that merry-go-round. So you go there, the gatekeeper will check, okay, your ticket is valid for the merry-go-round, and he will give you access. So this is Kerberos authentication, which happens in a way, right? And the PK int authentication is exactly similar, but here the only difference is, instead of using the user's password empty hash to encrypt the timestamp, in a PK int public key initial authentication, they actually make use of the user's private key, which is there on his certificate, right? So I'll talk about how he gets all that. And the same process follows. He requests for a ticket, he gets a TGT, and then all the stuff. So that's the basic background of the authentication protocols. Now let's talk about the PKI implementation in Microsoft. So this is done through a very special role inside of your Active Directory, which is called ADCS. So if you see here, it's a server role, right? I can say add roles and I can choose ADCS. So this is, it will give the certificate services which will be tightly integrated with the Active Directory in the background. And why do organizations use this? An internal CA? Because probably they want to use it for their own intranet internal websites, right? With their own internal websites, and probably for their own internal smart cards, or for message signing or encryption, right? Whatever you want it. So organizations usually use their own internal CAs for all this stuff. Now, the organizations have a choice of setting up their CA if they start off doing it, right? There is something called an enterprise CA if they want to, or a standalone CA. Most of the time, organizations will use an enterprise CA because that's how it gets integrated into the backend Active Directory. And then when you choose the enterprise CA, you have the choice of a root CA or a subordinate CA, right? And then once the CA has been developed and commissioned, it's ready to start issuing certificates. The way it does is, upon its creation, the CA has to create its own public key and private key pair first. And then it will use, okay, its private key by generating its own CA certificate, and it will sign that CA certificate with its own private key. So that means to say the root CA's certificate is actually self-signed by the CA itself, right? So look at this now. The glaring issue here is the root CA certificate is signed by the root CA itself. If someone were able to steal that, right? So game over, right? So the private key is gone and the root CA is also gone. So here, this is where you see the enterprise CA name, and this is the name. 560 Corp is, my fictitious organization for this demo. And here it says -CA. So it's an enterprise CA by that name. And then here, when you initially create a CA, it's valid for 5 years. So 2021, 2026. But of course, it is dependent upon the administrators. They can change it to 10 years or 12 years or what that matters, right? So this is how it goes. And the next step is, once the CA has been created, now the clients or the users, they need to do something called a certificate enrollment. At a very high level, a certificate enrollment is the clients or the users would seek out for that enterprise CA wherever it is there on the network. And then if they want to get enrolled, right, and they want to have certificates available to them, the first thing that the client would do is they need to generate their own public key and private key. So they will generate it, the client, okay, my laptop or my desk workstation, they will generate it. And then they will also, generate a CSR, which is the certificate signing request, right? So the public key will be placed inside of this CSR, and the CSR will also contain the subject. For me, it's example 560 Corp and the user is Khan, right? And it will also contain some kind of a template, a certificate template that I want the certificate to be mapped according to this template. And it will also sign this whole CSR with the client's private key, right? And now it will send it to the enterprise CA. When the enterprise CA receives the CSR, it will open it up because it has got the public key of the user already there on the enterprise CA. And then it will be able to see, okay, it has got the template. So it will first try and see whether the user is able to request certificates based on the settings inside of the template, right? And let's say it checks out. Then the CA will also check on its own database whether the user has got proper permissions to request a certificate, right? Whether he belongs to that group or whether he has, he gets what he's requesting the right certificate. If everything checks out, the CA will create a certificate and sign it with its own private key, and it will say, hey, take it. So the client will receive that certificate, which is now signed by the CA. and this certificate will be binding the identity for that user with its public key and private key, right? And the applications can start using them. So like this here, right? This has been issued from an organization and issued to this guy, low privilege user, and it has issued by this certificate here, where you could see my laser lights, 560 corp, and this, and it says valid from 2021 to 2023, right? And then the next thing for us to know is the certificate templates. I told you the guy who's requesting for the certificate will also, as part of his CSR, will send a template, certificate template. A certificate template is nothing but blueprints of settings that the CA can use to create a certificate. So what will the blueprint contain? It will contain, who's the subject for whom the certificate is needed for, or what is this certificate for? Is it needed for client authentication, or for smart card, or how long is this certificate valid? There's lots of settings there, and based on the template, the CA will create the certificate and it will send it out. So if you see on the right hand side where I have this thing, I don't know whether you're able to see my laser beam there, maybe because I'm not live, but you could see there, I have highlighted certain things there, the validity period, and I have highlighted the template name and the, all this stuff. Okay, so these are, the stuff according to which the CA will now create the certificate. Now, some things that you have to know, which will lead to a big havoc situation in organizations, is these templates, they are inherently misconfigured. I mean, out of the box, right? And most of the time, because certificate services installment is it's not really easy, right? And the administrators don't really know. And if they just go ahead and start using this in a default state without really bothering, what they turn on and turn off, it can lead to a lot of chaotic situations, right? And the first thing inside of this certificate template is something you have to know is called EKUs, which stands for extended key usage. It's an attribute. In the Microsoft parlance, it is also known as enhanced key usage, right? This actually dictates how the certificate is going to be used. For example, is this certificate being going to use to client is going to use to get connected to the domain as like a client authentication, or for encrypted file systems, or for smart logon, or whatever, right? So you can see on the screenshot I have there the template extensions and where you can go. Now, if an administrator does not know whether what is the difference between a client authentication and a secure email, if he just clicks and makes them open, right, he is making himself up for a big situation. So I'm going to talk about it now. Something else that are part of the default templates is something called this thing here on your right hand side on the topmost screenshot, called subject name. Okay, which is also called the subject alternative name, right? This allows additional identities to be bounded to a certificate, right, beyond just the subject or the original subject of the certificate. For example, in HTTPS, in the HTTP world, if you have a web server, and then this web server has got a TLS SSL certificate, right? And this web server will be having multiple domains inside of it, right? And it will be having just one certificate. But if you connect to different domains, right? The software will be able to route it properly because of that SAN, where it will go to different. So here, this is where I wanted to show you some demo as well, but I'm very quickly going to conclude this. So there is a situation here which happens, right? If someone can actually do some dangerous stuff here, like instead of the SAN, if he also supplies this, he can actually add a domain administrator as part of that, and someone can take over that, right? So I have two demos for me, but I'm going to show you only one now for the sake of time. All right, so let's get started. I hope, let me know if you're able to see my screen where I'm launching my demos. Are you able to see my screen for a demo? Can you see my screen?
Yeah, we are able to see.
Okay, so here I'm just explaining the second part of the attack, right? So this is a second demo where someone can actually go ahead and become a domain administrator just by that misconfig. So this is an attacker. He's logging in on his attacker machine, Kali, and then I have some steps planned out for him. These are the steps that I'm going to do. So the first step is to run something called an NTLM relay X, okay, which is nothing but relaying the NTLM connection, okay, back to the ADCS server. I was for the sake of time, I was not able to show you that when you check out the ADCS, you can find out the web endpoints for that. So here, this is the web endpoint. So I'm trying to connect to that ADCS server by something called an NTLM relay X, right? And then let me continue here. So I'm now using a template called domain controller. I'm waiting for someone to connect to me, right? So on my next slide here, sorry, look, I have started my thing. I'm listening. I'm an attacker waiting for this. And here I'm coercing a domain controller, yeah, to help to get connected to that attacker machine as a low privilege user. I'm giving the low privilege user, and he just gets connected, okay, with a very normal user rate. And this is the attacker machine, and this is the machine of the domain controller, okay. And then he gets connected there. And then what you see is going to happen here. You see, very immediately, right, it gets connected. I'm coursing the domain authentication. You see here a certificate got generated. This is the PKI certificate for the domain controller, which I as an attacker is now I'm able to steal this. So this is the certificate, yeah. So I'm going to quickly advance this. So I got that certificate, yeah. So now let me move a little bit forward. So I'm coming in here as to this attack, to this victim machine, where I'm logging in as the low privilege user. And look, I'm connected to the domain 560 corp. Let me slide it here a little bit fast. So I'm here, and again a little bit more sliding here. So here I'm showing you I'm a normal user. You see, the low privilege user is a normal user, but my goal is now to become the domain administrator, right? Just by stealing that certificate. Okay. So now here, again, go back a little bit fast, and for the sake of time. All right. So now here I'm trying to pass in the certificate, that I'm stealing it from my attacker machine, and I'm going to request a ticket granting ticket. Okay. So here I'm saying this. I'm asking Rubius is a software. Give me a ticket granting ticket for the overmind is the domain controller account, and here I'm pasting in that certificate. Yeah. So I'll just slide it here. So I've pasted the certificate here. And then you see here, it is asking for the ticket granting ticket with the certificate, right, with the PK int. And now the certificate is injected. And if you come back a little here, successfully injected, right? And now when you come back here, now I'm able to, steal the password hashes from the domain controller, right? So now what I'm going to do, if you look this very clearly here, I'm trying to run Mimikatz. So in Mimikatz, with that injected certificate, I'm now trying to do a DC sync where I'm stealing this password. The passwords are dumped. I can also go a little bit far and steal the administrator's NT hash. So I'm stealing the administrator's NT hash here. I will copy this his administrator password. I will go back to my attacker machine, and here on my attacker machine, I'm going to fast forward here. I'm now trying to use that NT hash to get connected as administrator on my attacker machine, right? So little bit, yeah, I'm already there. Just freeze it here. So if you can see here, I'm trying to run this. Just let me, for the sake of only 1 minute, yeah, only 1 minute, yeah. So here I'm trying to run that now as an attacker. I'm already there. So here, yeah. So I'm running that. I got connected to the Windows machine. If you see IP config, this is the domain controller 10.10.10.250, right? And then I am there inside of that machine. Host name is over mine, that's a domain controller. Who am I? I'm the administrator, right? So just from a normal privileged user, I was able to become the domain administrator of that system. So that goes to say, how big dangerous stuff this is, right? And certain mitigation stuff is already here as part of the slides. I will share this with you. What can be done to stop this? In conclusion, right? This is extremely sensitive, and attackers are having a field day today because no one knows about this. It's a very recent research, and this can lead to a lot of chaotic situations. And that's it. Over, handing over the mic back to the stage. Thank you so much.
Thank you, sir, for discussing these mitigation strategies for the PKI abuse in Microsoft Active Directory. And we would also like to have your video that you have just shown us so that we could upload it in our website for our audience and for our whoever wants to see and research further.
Yeah, sure. No worries. I can share that with you.